Today we're going to be doing a demonstration of the intermediate axis theorem. This is for extra credit in Scott Kelly's dynamics class, Dr. Scott Kelly. Right now we have our accelerometer data tracking on our phone. We have X, Y, and Z direction accelerometer measurements going on. 1g is the acceleration of gravity. So in this position, it's going to have 1g in the z direction, which is through the phone downward. In this position, as you can see, I'll put it up on the side, this is 1g in the y direction, accelerating down that direction. And then in this orientation, it is 1g in the x direction, which is accelerating in that downward direction. So, if this phone were to move in more than 1g, for instance, if I were to throw it and it were to rotate, or rotate this direction, that would cause different axes of the acceleration to change and be more than gravity. So if the phone is flipping, its acceleration in the z, x, or y direction will be greater than 1. So anytime we see a value over 1, we know that that is an acceleration in a certain direction. So the intermediate axis theorem, the way it works is that it says that there is a moment of inertia around each axis. So of this little iPhone, there's an axis going through of the primary axis. And these primary axes are the axes at the point that is the same as the center of mass. So the center of mass of our iPhone here is in the center. And so our primary axes go through the center of the iPhone, down the center of the iPhone, and then out of the center of the iPhone, which would be this direction. So that's our three primary axes. Now, the intermediate axis theorem states that the moment of inertia that is not the greatest of these three and not the least of these three, but the intermediate of these three, so the moment of inertia that isn't the greatest and isn't the least, rotation about this axis is unstable. Whereas the greatest moment of inertia rotation about an axis will be stable, and the axis with the least amount of moment of inertia will also be stable. So we're going to prove that today, tracking our accelerometer data and spinning in across different axes of the iPhone. So the first axis that we're going to spin across is going to be our down the center axis. So this is going to be the axis with the least moment of inertia. I'm going to do this by rotating the phone in this direction. I'll slow down the video so you can see it better. But I'm just going to I'm going to hold it very steady and then give it a spin across the axis with the least moment of inertia. So here we go, 3, 2, 1. There we go. So there we go, that's our axis with the least moment of inertia down the center of the phone. The next axis that we're going to test is the most moment of inertia, which is the most mass, the furthest away from the axis. So that's going to be through the center of our phone right here. To do that, we're going to hold it very steady and rotate it in this direction. So it's going to be rotating like this. I'm going to do it flat so it's easier to see on our final results. So 3, 2, 1. There's a good spin. The last axis that we're going to test is our intermediate axis. So we've already tested the axis with the largest moment of inertia, which is through the center here of our iPhone. We've tested the axis with the least moment of inertia, which is down the center of our iPhone, so that the mass is distributed that way. But now we need to test the intermediate axis, which is across the iPhone. So this is not the greatest moment of inertia and also not the least. So to do that, we're going to be flipping our phone in this direction. So, we're going to hold it steady to begin the test. And to do this test, I'm only rotating in one direction. Any flips or anything it does afterward, I'm not in any way trying to induce. All right. So, today we have shown that the intermediate axis theorem is a testable theorem that can be measured and is in fact valid. We have shown this not only with the video of the stability of the axis in slow motion, but also the direct evidence from the accelerometer data that shows that on the stable axes, there's only acceleration in one direction. So if you go back and look, the circled acceleration data was only in the x or only in the y. And for the intermediate axis, there was acceleration not only in the x but also the z.